Bismillahirrahmanirrahim. Today we will discuss about exercise 3.3, next topic of class 10 mathematics, that is available on page number 58. We have already discussed question number 1 and question number 2, that is relevant to third proportional and fourth proportional. Now, question number 3 is find the mean proportion. The first part is 20 and 45. We have already knowledge about what is or what are proportions. Proportion is basically the equality of two ratios. For example, A ratio B proportion to C ratio D. These are called extremes, and these are called means. So we need to find the means here. Means are these middle terms, and these are extremes. So to find the mean, we need to suppose any variable that must be mean, and we need to find it. You can say that these are extremes. So to find the mean proportion, you need to write it as 20 ratio. The mean proportion is x. Again, mean is x because these both are means. So we need to let them with any variable like x. And ratio, the last is 41. So these both are extremes, and we need to let the means with any variable. These are extremes. And these are means, which we need to find. So you know that product of extremes, we need to say 20 multiplied by 45 is equal to product of means, x multiplied by x. 20 multiplied by 45 means 900 is equal to x multiplied by x is x squared. We need to find the value of mean. So x squared, we need to find only the value of x. So apply square root on both sides. This square must be cancelled to this square root. 900 square root is 30, and you need to put them with positive and negative. This plus and negative sign is not. You know why? From first and second chapter, we have already knowledge that why we put here positive and negative sign. This was part number 1. Part 2 is 20x cube y raised power 5 and 5x raised power 7 and y. These are extremes, and we need to find the value of means. So one thing you need to remember that x is already being used, y is already used. So you need to make another variable to suppose 20x cube y raised power 5 ratio. Now you need to suppose any variable rather than x and y. You can say that that is z. These are means, and then 5x raised power 7 and y. Extremes, and means z multiplied by z into say z square, and 20x cube y raised power 5 multiplied by 5x raised power 7 y. So z square, or you can say that this is z multiplied by z Now 20 multiplied by 5 means 100. X raised power 3 and x raised power 7 makes x raised power 10. Y raised power 5 and y raised power 1, 5 plus 1, 6. Now apply square root on it. This square can cancel with this square root. Positive, negative. 100 square root is 10. X raised power 10 square root mean to say 1 over 2 power is x raised power 5. And y raised power 6 square root is y raised power 2 3s are 6, so 3. These are mean proportion. Part number 3 is relevant to this, and we will solve part number 4. That is x square minus y square, then x minus y over x plus y. Again, we need to find the mean variable, mean proportion, and x and y are already being used. So you can say that x square minus y square, this is extreme. Then you need to let any other variable like z, both are means, and then x minus y over x plus y. These are extremes, and these are means. The product of means is equal to product of extremes this z multiplied by this z makes z square. Now you know that x square minus y square, it is a formula. You need to open it, that makes x plus y into x minus y multiplied by x minus y over x plus y. Okay, cancel them, x plus y with this x plus y. And you are left with only x minus y whole square. Z square is equal to x minus y whole square. Now you need to remove this square. For that purpose, apply square root on it. And z is equal to, this square can also cancel to this square root for positive, negative, x minus y. This was your question number 3, that is totally relevant to mean proportion. Now the last question of this exercise is question number 4. Find the continued proportion. Continued proportion is, you need to find the unknown variable value. The unknown variable here is present p. So you need to make continue another time like 5, then ratio, then p. Then again you need to continue this, and you need to just only find this value of p, unknown variable, and the last is for 45, and that's it. And rest of the method is same. P square is equal to 5 multiplied by 45. 5 5s are 25. This makes 225. Now apply square root on it. Plus minus 15. That's it. Just you need to find the value of unknown variable and you need to repeat, you need to make continuation one more time, and the rest of the method is same. Second part is again the same, continued proportion. The unknown variable is presented here. So 8 ratio x may continue this variable, and again 18. This x multiplied by this x square is equal to 8 multiplied by 18. 8 8 is 64, 144. So after applying square root sign on it, plus minus 12. And that's it. The part 3 and part 4 are same. Okay. We will solve part 3. Now, for continued proportions, you need to write 12 ratio 3p minus 6. Again, repeat it. Now, product of extremes is equal to product of means. This 3p minus 6 and this 3p minus 6 makes 3p minus 6 whole square, or you can must write it as 12 multiplied by 27. Now one thing, this 3p minus 6 and this 3p minus 6 both contains 3 common here and here. You can write it as 3 common. P minus 2, because 3 is common here. 3 2s are 6. Again from here, 3 is common. P minus 2 is equal to 12 multiplied by 27. So 12 multiplied by 27, answer is multiplied by 12. So 7s are 14, 5, 4, 5 and plus 7, that is 12, and 324. Okay. Now this is 3 3s and 9. P minus 2 and P minus 2 makes P minus 2 whole square and again 324. Now this 9 is multiplying and we're going to divide there. So P minus 2 whole square is equal to 324 divided by 9. Now we can check whether we can divide this through any table, like 3 3s are 9, 3 1s are 3, 0, 3 8s are 24. Okay. Again, 3 1s are 3, 3 3s are 9, 3 6s are 18. So P minus 2 whole square is equal to 36. We just need to find the unknown variable value, that is this P. Now apply square root on it. P minus 2 whole square is equal to 36 square root. Squares cancel with this square root. So P minus 2 is equal to plus minus 36 square root is 6. Now you have two ways to find it. First, just P minus 2 is equal to positive 6. And then P minus 2 is equal to negative 6. This minus 2 will be there. So P is equal to 8. This minus 2 will be here. So the values of P are 8 and minus 4. And that's it. Question number 4, part 4 is again is the same thing. You can easily do this. This was your exercise 3.3. Now there are some theorems relevant to exercise 3.4 that are most important. First theorem is for, we know that A ratio B proportion to C ratio D. Proportion. The first theorem is theorem of invertendo. Invertendo theorem is A ratio B is equal to C ratio D, or A ratio B proportion to C ratio D. We can write this thing as A over B is equal to C over D. You know that A ratio B means A over B, C ratio D means C over D, and proportion sign is equalities. After applying the theorem of invertendo, you can revert, you can inverse these values. This is A over B, we can write it as B over A. But the equality will sustain only if we invert this equalities, this left hand side, and also with this right hand side, that this is C over D rather than D over C. Now A over B becomes B over A, and C over C. This is property. A over B, we can write it as A ratio. So what about this B over A? We can write it as B ratio A. And this equality is proportion, and D over C is B ratio. And that's it. So A ratio B proportion C ratio D. After applying invertendo theorem, it becomes B ratio D ratio. This one of alternando theorem. Alternando theorem is if A ratio B proportion to C ratio D, we can write this thing as A over B is equal to C over D. Now, applying alternando theorem, we can alter these values. For example, this will divide and this B will multiply. You can interchange these values easily. Like this becomes A over C is equal to, and B will be here, D over D. Just alternate these values just by applying alternando theorem. So now it becomes A ratio A over C is equal to B over D. So how we can write it in the ratio form rather than A ratio B, it becomes A ratio C. And this equality is proportion and it becomes B ratio. This is just because of we applied here alternando theorem. This was second theorem. These are very easy. The third theorem is componendo theorem. Componendo theorem is simply this about addition, like A ratio B proportion to C ratio D. We can write it as A over B is equal to C over D. Now the thing is, what is A ratio B answer is what is C over D answer. If we are going to change then its numerator, then that changing will also must apply to right hand side numerator. For example, if I am going to add this denominator to this numerator, for example, A plus B and denominator will be same. Just we are going to add this denominator to this numerator. Then changing will apply to right hand side also. We can't write it as only C over D, because C over D will only equal if and only if this is A over B. But if we change this numerator, then we must need to change the right hand side numerator also. What changing applying here must also be on the right hand side. What we have applied there, that is, this denominator will add to this numerator, and this must be also like this. This denominator must also be added to this numerator. Now the thing is balance. This denominator will also must be added in this numerator. So both have same effect. That's why these are same, equal. So now we can write it as A plus B ratio D in proportion C plus D ratio D. This was theorem of componendo. Now, the fourth theorem is about dividendo. Componendo theorem is for addition and dividendo theorem is for subtraction. Same the thing is like A ratio B is called A over B is equal to C over D. Now the thing is that if we are going to apply effect, what on left hand side must be on right hand side. For example, if I'm going to subtract this denominator to this numerator, this denominator subtracted by this numerator, then the thing is balanced only if the same effect if we are going to applying here on the right hand side. This must be D is subtract there. Now the both things are balanced. So A minus B divided by B is equal to C minus D divided by D. We can write this thing as A minus B ratio B is equal to C minus D ratio D. This is basically the dividend theorem, and that's it. We have done componendo, same thing with addition sign, and we have done dividendo, same thing with negative sign. Now the last theorem is the mixture of componendo and dividendo. It is very easy, that we will use more and more in this exercise. Its name is mixture of both, componendo, dividendo theorem. Okay. A ratio B, we can write it as A over B. C ratio D, we can write it as C over D. Now, you need to apply here componendo, addition property, dividendo, subtraction property. So how we can apply here? The best method is addition and subtraction property must be apply here. We can apply the same effect on the left hand side and same effect on the right hand side to balance the situation. So for componendo, we can add this denominator in the numerator, just like in the componendo property. And for dividendo, you need to subtract the same thing in the denominator. Now this is componendo effect and this is dividendo effect. The thing is balanced only if and only we are going to apply the same scenario on the right hand side. You can write it as C plus D over C minus D. Now the things are balanced. There is no compulsion about that you need to apply addition property on the numerator and subtraction property on the denominator. No compulsion on that. You can also apply. You can also revert this thing, a minus b on numerator and a plus b on denominator. And the same thing you need to apply on the right hand side for balance. You can't do that you are applying subtraction property on the numerator here, but addition property on the numerator here. You need to apply the balance situation if this is subtraction above, and this must also be relevant to subtraction. So finally, you need to write this in the form of ratio and proportion. So you can write it as a plus b ratio a minus b, then proportion sign, then c plus d ratio c minus d. This is componendo, dividendo, or you can write this thing as a minus b ratio a plus b, proportion c minus d ratio c plus d. Both are called componendo and dividendo property, either this or either this. I hope you understand this thing very easily. This is not so much difficult. These are very, very, very interesting questions. So now you can easily understand that how we can apply these things on it. Now, if you have any question regarding today's lecture or any previous lecture, you can ask it now, and thank you. In the next lecture, we will apply these theorems through exercise 3.4. That's it.